All right, day 2. Let's get it. Just want to take a moment to say Akia, Jasmine, Ariella, Christian, Arian, Nicholas, Ainsley, Phoenix, Isaac, Ben, Aiden, Ivory, Talia, Jordan, Christopher, Madison, Alana, Karina, Cami, Kennedy, Imani, Cameron, Katie, Allison, Aiden, Small, Donovan, Melvin, Noah, Ian, Peter, Harini, Logan, Jackson, Miles, which is Drew, Christopher, Buller, Dejanay, Zaria, Courtney, Sadu, Lena, Hannah, Aniko, Bella, Zaki, Maddie, Emma, Ethan, Mika, AJ, Brendan, Aishatu, Alberto, Emma, Sir Malachi, Mariah, Malathia, Liam, Chloe, and Chris Wilson. I miss you, and I know you're doing your thing on these notes and all that good stuff. This is day 2. Let's go. All right, so yesterday we talked about an exponential function is a function in the form of a y equals ax, well, a times b to the x. All right, where a cannot be 0. I did not go over this, but I'm going over it today. It has to be greater than 0, and b cannot be equal to 1, and x is a real number. There will be some kind of assessment on this, making sure you understand what I'm about to break down to you, because I didn't go into details because I knew it was going to be too much yesterday. So let's talk about each reason. A cannot be 0. Let's talk about that. You're just going to be given this, and you're going to be asked to explain to me why these rules are what they are. So if we're saying let's go to the galaxy today. No, that's not the galaxy. The galaxy is right here. We're in the galaxy. Y'all see the galaxy? Y'all see the stars, the constellations? All right. I think that's where did it? Oh, the bully's back. Give me a second. I had to go handle my bully. All right, there we go. Oh, this is really looking bad. The bully might be winning. So, yeah, if we look at the galaxy, yeah, whatever. Let's leave the galaxy alone. All right, so it says where a, it keeps disappearing, where a is not equal to 0. So, y'all, if a was 0, you will have y is equal to 0 times bx, which is give you 0. Okay, so a can't be equal to 0 because let me make this I don't know why this is disappearing, but a cannot be 0 because you will have. All right, so I have to figure this out. I think I got the bully away. All right, so a can't be 0. That's my y equals 0 right here. Yay. A can't be 0 because if it was, y would be 0, which would make this a linear function, and y equals 0 is the x-axis. How do I know that? Because this is Hoy. Y equals 0. Let me slow it down. Y equals 0 is the x-axis. How do I know? Because y equals a number is Hoy. So in this case, you'll say it's a horizontal line at 0. Well, what's a horizontal line at 0? That's the x-axis, y'all. Horizontal line at 0 is this line right here. Whoa, bad boy, gotta lose a little weight. That's the bully. Put him down. Gotta lose a little weight, buddy. So yeah, we're having technical difficulties this minute. Okay, sorry about that. As I was saying, y equals 0 is the x-axis. It's this axis right here. Because again, this is saying a horizontal line with a slope of 0 that crosses the y-axis, right? So it's at 0, and a horizontal line at 0 would be the x-axis. All right, so that's what that means. Okay, so a cannot be equal to 0 because if it was, it would be a linear equation of y equals 0. That's the first thing. You might want to write that down somewhere. There are 3 things that we need to talk about. B has to be greater than 0. All right, so you don't know this, but I'm gonna teach it to you anyway. You can have B has to be B has to be greater than 0. Okay, so you might want to put this on a separate sheet of paper just so you have these rules with you. B has to be greater than 0 because B is some power to x. You will learn this in math 2 or 3 that powers can be fractions. So for instance, b to the 1/2 power is really the square root of b. Okay? So again, b to the 1/2 power is the square root of b. So you can't have negative square roots, because if I say the square root of -4, well, there is no number multiplied by itself to give me a negative number, because a negative times a negative is a positive, and then positive times a positive is a positive. So this is where we entered the realm of imaginary numbers, which you will see definitely in math 2. So b has to be greater than 0, because you can't take the square root of a negative number. Okay, so that's why b is greater than 0. So that's the second thing. B has to be greater than 0, and b cannot be equal to 1. B cannot be equal to 1, everybody. B cannot be equal to 1. Again, you're writing this down somewhere separately, because this is a mess up here. Write it down somewhere separately. Pause the video, write it down somewhere separately. Okay, b cannot be equal to 1, because if b was 1, then it'll be y is equal to some number a that's not 0. So it'll be like 5 times 1. Well, that's going to be linear. Okay, that defeats the purpose. You won't get an exponential function, because you can't say 1 to any power. 1 to the any power is 1. So b is not equal to 1. So that's why these stipulations are here. A can't be 0, because you'll have a linear function, which will actually be the x-axis. B has to be greater than 0, because if it's not, you can have the square root of a negative, and that's not possible. So b has to be greater than 0. And then for real numbers, and then b cannot be equal to 1, because if it was equal to 1, again, that will make that linear. And x is a real number. I just told you there are such things as imaginary numbers. So, x is a real number, which I'm not going to go over. So really, I care about the a, the b, and the b. Now, I've told you the stipulations and explained to you the stipulations or the parameters involving an exponential function. Now, let's get into what I really want to deal with, which is what we call the asymptote. So I am going to erase this stuff and deal with this asymptote situation. All right, so the asymptote is the line that curves. Okay, the line that the curve approaches but never intersects. That's supposed to be the curve. The line that the curve. I was like, what in the world? The curve approaches but never intersects or crosses. So let's talk about this. This is a mess up here, so let's look at here. Let's look at y equals 2x, which is what this is right here. Okay, y equals 2x is what that is. So when I look at y equals 2x, why would this curve never touch 0? That's what this is saying, because the line that is approaching, get my highlighter. Y'all, I'm doing some good teaching. Watch this good teaching stuff. The line that it is approaching, is the actual x-axis, which is this right here. Okay, so we're saying, man, it's not steady at all. Gosh, we are saying that this line will never touch the x-axis, or y will never be 0. Let me show y'all. Watch this, everybody. Y can never be 0. So we're saying that this line here, y equals 2x, will approach the x-axis but never will be 0. The bully is back. All right, so why will it never be 0? It will never be 0 because what, y'all? We're saying y is equal to 2 to the x. If x is 0, what is y? Y is 1. So what we're saying is that I can have some negative exponents, to make this number really, really small, but there is no power that I can raise a number to give me 0. Okay? This is something y'all have to know about the asymptote. I'm going to put it right under here. There is no power I can raise a number to, I could just say to equal 0. Now, I told you I'd put it on another paper. So you just like, I ain't got no room to put it there. Well, put it on your other piece of paper like I told you to. There is no power I can raise a number to equal 0. A number to equal. Maybe I should have to equal 0. All right. So you can't raise anything. You know, 2 to the 0 power is going to be 1. Now, you can raise these to some very large negative powers, you know, but at the end of the day, you still will never get 0. You will never get 0. So y can never be equal to 0. So when we are looking at this line right here, it's going to get close. It's going to get really close to 0, but it'll never be 0. It can never be 0. So this horizontal line of y equals 0 is your asymptote. Okay? Y equals 0 is your asymptote because it's the line that the exponential function approaches but never crosses. Okay? Let's talk about the next one. This one looks like it's approaching, this number right here is 3. So it looks like it's approaching 3, but never crosses at 3. Why is that? In order for this line to cross at 3, this right here has to be 0. That's the only way that y will be equal to 3. But it can't be equal to 0 because there is no power that you can raise this number to give you 0. So the asymptote is 3. So the line that this approaches is y equals 3. Where is this line approaching? All right, if we follow the line, this is right here is negative 3. Oh, sorry. Right here is negative 3. So what's the asymptote? The asymptote is y equals negative 3. The asymptote is the line that the curve approaches but never crosses. It never crosses y equals negative 3. What do y'all notice? The asymptote here is 0. On this first equation, y equals 2x, the asymptote is 0. On this equation right here, the asymptote is negative 3, and this is 3. So where's your asymptote? It is right here. It is the number that you are adding to the equation or subtracting to the equation. Okay? Over here is the same thing, everybody. This is approaching 3. Asymptote is right here. This is approaching 0. The asymptote is right here. Okay, plus or minus 0. This is approaching negative 3, but never crossing. Y is approaching there. The asymptote is right there. Right here, people. Oh, I should do all of that. All right, so that's a lesson on the asymptote. It is the y equals a times b to the x plus or minus whatever this number is. And we know it'll never approach that number because in order to approach this number, this value has to be 0. And there's no way for it to be 0 because a can't be 0. And I think it makes sense, y'all. It makes perfect sense. I mean, you might want to rewind it just to make sure you got it. But there is no power I can raise a number to equal 0. There is no power I can raise a number to equal 0. All right, that's probably a better way for me to say it. Whatever. All right, so tomorrow's lesson will deal more with this. I'm showing you this because you need to know this, and this video is not going to be that much longer because the rest of this stuff is pretty simple. Because you have formulas and all you're doing is plugging and chugging. But you need to understand this formula. This formula right here is where people get they mess up a lot, but y'all won't because I've learned to be a better teacher because of mistakes from the past. An exponential. An exponential function is a function of the form. It's become a little annoying. I'm gonna have to uninstall this so we can stop having these interruptions. An exponential function is a function of the form of y equals a times b to the x. We've been over that. A is the initial value, x is time usually, and b is the growth or decay rate. And we went over why, all that good stuff. So let's get into a word problem. You have $25. Your money doubles every year. Write an equation representing this situation. So start off simple. You have $25. So that's your initial value. A is 25. Your money doubles. What would that be? If your money is doubling, you're multiplying by 2 each time. So B is 2. So the equation is simply y is equal to 25 times 2 to the x power. You start off with $25 and your money doubles, that's the growth rate, doubles every year. Now you think this is easy, right? Yeah, this is easy. It is when we start to introduce the rest of the equations where people forget about your keys. So when you see doubles, triples, quadruples, it halves or it's cut in half, it's cut in a third each year, that is the growth or decay rate. When you have your growth or decay rate in the problem, that is your B. That's your B, everybody. This is your B. And this is your initial value. It does sound simple. It does start off that easy. It is when we introduce all the rest of the formulas is where people start getting confused. All right, so it says in many cities there is a rat infestation. Rats grow in alarming numbers. In some cases, the amount of rats can quadruple within a month. If there are currently 1,244 rats in an area, write an equation representing the amount of rats in the city, amount of rats the city can have in a month. All right, so it's clear that my initial value is 1244. It is also clear that quad, the prefix quad means 4. That's my growth rate. So my equation is simply y is equal to 1244 times 4 to the x power. But x represents months. And that's good to know, because if you don't say x is months, then when you think how many years, then that'll be 12 months. Okay? That's what you have to convert. So you have to remember that conversion in your head. All right, so those are simple. Yeah, I know, they're simple. Okay, so what I'm about to introduce are the rest of the equations. There are 1, 2, 3, 4 plus the exponential function equation. 5 equations that you need to know. 5 equations, yes, and they're pretty simple. The only equation that will, not be as simple as that one, but, after you practice and use it enough, you'll be fine. So exponential growth, exponential decay, compound interest, and geometric sequences. We will not go over this in the video. I'm going to say this when I come back, because it's the most complicated one, because it can throw people off, because it is yeah. All right, so we will talk about exponential growth, decay, and then today, exponential growth and decay. Tomorrow we will deal with compound interest, and yeah, let's go. So exponential growth, we've talked about growth, but we haven't seen the equation like this. So y is equal to a times b to the x. B has to be, no pun intended, greater than 1 in order for there to be growth. So the exponential growth equation is this right here. Okay, that's the equation. What you have underneath, man, I'm doing some good teaching right now. What you have underneath is the equation for any exponential function. So what I'm trying to show you is that y is equal to a. Your a is the same, but your b is 1 plus r. And we're gonna go over what r is, but I'm gonna tell you it's your rate as a percent. You're going to convert it as a decimal in the problem. So the reason why this is greater than 1, because I have 1 and I'm adding some decimal to it. So that's the reason why it's growth, everybody. Okay? That's the reason why it's growth, because b will always be greater than 1. That makes perfect sense, y'all. So here I have our parent function, y equals 2x, and we can see it. Oh yeah, these graphs don't match that. I just realized that. Yeah. Y equals 25x is exponential growth. Your a here would be 1. Right with me. Your a here would be 1. Your a here would be 2. Your b is 2. 2 is greater than 1. Your B here is 25. 25 is greater than 1. Your B here is 2. 2 is greater than 1. What do we call this again? The asymptote. All right. So this is an example. Growth, rising to the right. Growth, curving to the right. Growth, curving to the right. Leave me alone. All right, so that's the beginning part of the equation. Usually I can last longer with this thing, but this thing is trying to win. So now we have exponential decay. Decay, same setup. The decay formula comes from your exponential function. In order to have decay, b has to be less than 1. That's the key. So this is the official exponential function, exponential decay equation. Y is equal to a, which is your initial value, times 1 minus r, your rate as a decimal, raised to the x power. This is still in the form of y is equal to a times b to the x power. And the reason why we have decay, because b is less than 1. So this is decay because a right here is 1 and b is what? 0.2. 0.2 is less than 1. Okay, a right here is 1. B is 2/9. 2/9 is less than 1. A right here is 2. B is 0.05, which is less than 1. Okay? So that's why all of these are decay. This is rising to the left, curving to the left, curving to the left, or it's decreasing, decreasing, decreasing. All right, so let's practice. The practice of this is going to be easy, y'all. Watch this. All right, so exponential growth, here is the equation. A is your initial value. R is your rate of change as a decimal. X is time. All right, we replace, this may be T for time. So sometimes you'll see it A times 1 plus R raised to the T power. So suppose the population of deer in a region was 3,500 in year 2000. Since then, the population has grown by 3.5% annually. What will the approximate population be in the year 2020? So let's use our equation. Y is equal to A times 1 plus R to the X power. Yes, get used to writing the equation first. Okay, so now that becomes Y is equal to, what's my initial value? 3,500. 3,500 times 1 plus, but this as a decimal. Please remember that 3.5 as a decimal, you can divide by 100 or you can move the decimal to the right. Sorry, that's your left. To the left twice. So 0.035. And now it's they're asking what would be the population from 2000 to 20. Oh, it's 2020, y'all. Look at here. Look at here. And so what's that time? That time is 20 years has gone by. It is 3.5 annually. Annually means every year. So that's the reason why we're doing 20 years as opposed to 20 times 12, which gives you 240. So it's not months, it's annually. And now we just put that into the calculator. I'm going to do this because I want to talk about this for a quick moment. So we get y equals 3,500. And then this is going to be 1.035 to the 20th power. Now, I want to have a quick moment about this. So if you see this in a problem and you know this is exponential growth and the problem asks you, hey, what was the rate? Well, the rate is whatever's been added on to the 1. So if the problem says what was the rate? Well, the rate had to be 0.035, and 0.3035 as a decimal, as a percent, is 3.5%. So some problems are going to ask you that in the near future. What is the rate? That's a 20, even though it looks like 2 zeros. Yeah, I'm just trying. So the bully has realized that I've been putting it underneath the window, like down here. And now it won't even go down there without circling and buffering. Oh, the bully is evolving. Oh gosh. All right, so now we put this into the calculator. Let me pull up Desmos. You want to use Desmos Scientific Calculator? I'll be right back. All right, so if you look up Desmos Scientific Calculator right there. All right, that's what I'm using. And I forgot what the problem was. I think it was, let me go back. 3,500 times 1.035. Close your parentheses. This to the B power, raise it to whatever power you want, puts the 20th power, and we get, and the problem is asking for what? What are you asking for? Will be the population in 2020. So we're going to round to 6,964 people. 6,964 people. All right, told you it's going to be simple. Okay, bacteria grows at a rate of 7% per minute. If there are 200 bacteria now, about how many will there be in 10 minutes? Round to the nearest whole bacteria. So our formula is y is equal to a times 1 plus r to the x power, x meaning time. So our initial value is 200. Y is equal to 200 times 1 plus our rate as a percent, 7 as a percent, move the decimal to the left twice, we get 0.07, and then our x is time. This is per minute. They want in 10 minutes, so we put that to the 10th power. So this translates into, I know I can hear Nick like, why do I have to do all that? I already know. I want you to do this. Write it like this for now. You will graduate on your homework. All right, and then we come over here, and then we do 200 times 1.07. And then if you do shift 6, you don't have to do the A to the B button. And then, was it 7? What was the year? It's 10. Oh. Got out of my little zone. So we got 393 bacteria. All right, so that's exponential growth. That's growth. Homework will deal with growth and decay. All right, so let's look at decay. So let me line this up right. Hopefully the bully is staying away for now. Man, line up. All right, that's good. All right, same thing, decay. Remember, B is less than 1. That's why it's decay, everybody. All right, so the population of New Haven is this. In 2006, since the population has been decreasing at an annual rate of 2.9%. If this rate of decline continues, what will be the population in 2017? So clearly it's decay. All right, so y is equal to 148,220 times 1 minus, turn 2.9% into a decimal, 0.029. And we want to know from 2006 to 2017, that is 11 years. All right. And now we will say, I'm just going to put this in the calculator, 148,2020 times 1 minus 0.029. And then we're going to raise that to the 11th power. So we get 107,230. 107,230. So 107,230 people. All right, it's important to know that if we do 1 minus 0.029, that the number inside is 0.971. So when you see y is equal to 148,220.971 to the 11th power, you will know that this is decay. Why would you know that this is decay? Because this number is less than 1. Okay, so to find out what the rate was, simply subtract this number from 1. And then you'll get the decimal, and then turn the decimal into a percent. So to say 0.971, just like here, just subtract 1 minus 0.971, you get 0.029, and then 0.2029 times 100. Oh, I didn't do 0.029 times 100, and you get 2.9. That was the percent, right? So that's just working backwards. You will be asked to do that. All right, the last one. Y is equal to, I'm over 30 minutes. Sorry, 1500. We're just gonna go into the problem. We're not gonna write we can write the equation in the last one. 1500, that's 150,000. Depreciates, y'all. Depreciates 11%. So that's decay 0.11. And what will be the approximate value of the printing press in 6 years? It's depreciating 11% per year. So 150,000 times 1 minus, what is this? 0.11. And then raised to the sixth power. So this is money. So it's $74,547.19. All right, that's it, y'all. Exponential decay, exponential growth, understanding what they look like, knowing why they are what they are, the asymptote, understanding what that looks like, all the stuff you need to know, and understanding that there are sometimes, oh, y'all need to see this. There are sometimes there is no exponential decay or growth, because why? Why is there no decay or growth? Because you're giving the growth rate doubles. You're giving the growth rate quadruples. I was about to say triples, but quadruples. All right, you're giving the growth rate, it doubles. You're giving the growth rate, it quadruples. That's the reason why we don't have growth or decay. It's given to you. All right, I think this was a great day, good lesson, all that good stuff. It's been another Beast Mode production. This is Mr. O'Neal. Love y'all. We out.